Okay, let's talk about constructing or building linear functions. First, we're going to talk about starting values and rates of change. Those are critical to building a linear function. Then we'll look at a little bit more challenging example. So, first, reminder, the form of a linear function is just like our slope-intercept form. We have y equals mx plus b, where m is our slope and b is our y-intercept. But we can also think about those as two other things. We can think about the b as the starting value. So what do we mean by that? Well, if we put in 0 for x, the starting time of the function when x is 0, when time is 0, then this term will go away and y will just equal b. So that's the starting value. And then we can think about the slope as the rate of change. So whenever x changes by 1, how much will y change? Well, that depends on what this m number is, the slope. And it will, if m, for instance, is 2, when x goes up 1, then y will go up 2. When x goes up 3, then 3 times 2 is 6, y will go up 6. So this is the rate of change, the m value here. Okay, now let's look at an example. For your birthday, you get a $100 gift card to a local bookstore. Each week, you treat yourself to a $5 book. So let's ask ourselves a couple of questions here. What is the starting value, and what's the rate of change? Well, the starting value is that $100 that you have on the gift card to begin with, and the rate of change is how much the amount on the gift card changes whenever you buy a book, and that would be negative $5. You might think $5, but really it's negative 5 because the gift card is going to go down $5 each time you buy a book. So now we can take that starting value and rate of change and put them into our standard linear function form. So we can say y equals negative 5x plus 100. And when we graph this, we can see that we start with that starting value as the weeks go by here on the bottom. At 0 weeks, you start with $100 on your gift card. So the y amount is the number of dollars on the gift card, and the x amount is the number of weeks that have gone by. And then, as the weeks go by, you'll eventually go to 10 weeks here on this graph, when you can put 10 in for x, and negative 5 times 10 is negative 50, plus 100 just leaves 50. So you can see that using this equation, you can calculate that after 10 weeks, you'll only have $50 left on your gift card. And you can even draw the straight line, and you can calculate any of the weeks. You can say, okay, well, after 5 weeks, how much will I have left on the gift card, etc. So that's a pretty easy example. Let's go to a more challenging example over here. You own a bakery that makes muffins. The graph below represents the number of dozens of muffins you have, and that's going to be on y. Okay, so let's just look at the graph here. This is the number of dozens that you have. Okay, and let's go back up here. As a function of the number of hours since the bakery started work that day, and that's x. So x is the number of hours. Write a function for the situation. Okay, so we have two values here that we're given, the value 3, 4, and 7, 6. And then we are given that it's a linear function. So what we have to do is we have to find something that's in y equals mx plus b form. And we want to think again about the starting value and the rate of change. Okay, let's look at the rate of change first. We want to understand how much this is changing, and that's really the slope. Okay, so if we apply our normal slope form down here, down below here, m equals y2 minus y1 over x2 minus x1, we can use these 2 points to calculate the slope. So let's go ahead and put those 2 points into our equation. So remember, we'll call the point 7, 6 y2, or x2 y2, and the point 3, 4 is x1 y1. So when we have y2 minus y1, it's going to be the value 6 minus the value 4. And then the x2 minus x1 is the value 7 minus the value 3. And we can calculate that. 6 minus 4 is 2, and 7 minus 3 is 4. And then we can simplify that to be 1/2, or what is that in decimal? Yeah, 0.5. So let's go ahead and write our rate of change up here now as 0.5. Now, let's try to find that starting value. That's the other thing we need to create our function. Now you can kind of read it from the graph. It looks like it's about at 2.5, but we don't want to be inexact. We want to actually calculate it. So what we can do is now that we have this m, the 0.5, the rate of change, we can use one of the points and we can actually calculate b exactly. How do we do that? Well, let's go ahead and rewrite our equation with one of the points in there. So we'll use the point 3, 4, and so instead of y, we'll put 4, and instead of x, we'll put 3, and we know what m is, that's 0.5. We don't know what b is yet, but that's what we're going to calculate here. So now we can just solve this equation for b. So we go ahead and multiply the 3 times the 0.5, so that's 1.5. And then we subtract 1.5 from both sides, and then we get 2.5 equals b, or we can write it as b equals 2.5. So now we were right, it was 2.5, but now we're confident that that's the exact value. And now we can go ahead and write our function with the not only the m value, but also the b value. Let's go ahead and put that starting value up here first, and then let's go ahead and write the function. So here we have the y equals mx plus b, and we used the 2 points to calculate the rate of change to get 0.5, and then we use that and one of the points to calculate b, and now we have a complete function here. Okay, good job.